Heather, we're going to divide this up into 3 sections. So the first section today is going to be getting to know you, so getting to know me section. The second section is going to be getting down to business. So we're going to talk a little bit about business. And the final section is a rapid fire section, our race to the finish line, and we'll have a little bit of fun in that one. If that's
Sounds
okay.
like fun.
You're a regular on the speaking tour in North America, on the conference tour in North America. Is it something you enjoy, and why?
Oh, I definitely enjoy it. I'm a people person. I like talking to people, hearing their opinions, hearing their thoughts, particularly where the industry's going, what's new and interesting. And I find the conference as conferences as they used to be pre-COVID, were just the absolute best way to do that. Informal conversations gives you so much insight into what's going on. And getting to know people personally is great.
Yeah, I agree. That's the thing I enjoy the most about being out with the customers is
absolutely.
You get to see people, get to meet with people, connect with people. And
yes.
I love that there's an appetite within the industry to educate. I mean, you're one of them. Another question, you know, all of our careers have been shaped by people. And it's always interesting to look back on how they shaped that career. Is there somebody that has been really influential in your career that you want to write?
I would say my aunt. She became a professor at the University of Western Ontario early when she was quite young, probably one of the first women professors in the dental school at Western. And certainly she's been my mentor and my sounding board, and gives me confidence to know that yes, women can do science.
Oh, that's amazing. I couldn't agree with you more. My aunt is a doctor of pharma. She was the president of the Addiction Research Foundation in Toronto. And it's amazing to see women in science and, you know, really trailblazing leadership.
Yeah, definitely trailblazing.
Absolutely. So thanks for sharing that. Another kind of reflective question. You know, I'm not going to use cliches about what this year has been like, but it's been challenging.
It has.
What has COVID taught you?
It taught me that I get to enjoy this career a few years longer than expected.
Great answer. Heather, PFAS and PFAS testing has consumed a lot of our time over the last number of years. What is PFAS for the people out there? What is PFAS and what do those compounds do?
PFAS is an acronym that really means an enormous class of industrial chemicals. They have fluorines and carbons in them, which makes them unique. We've been using these compounds since the 50s. They are an enormous class. They have many very helpful properties, bringing lots of useful things to our lives. However, they also have a more unfortunate side that we're starting to learn more about now. Exposure to some of these chemicals isn't so good for us and is causing problems in our environment. And I guess you don't get anything that's just purely good. We have to start watching out for the more unfortunate side of the PFAS family.
Yeah, good point. The question I would have is, how concerned should people be? I mean, some people are erring on the side of it's not as concerning as some would think, and others think it's a little bit more. Where do you sit on that scale?
I think this is not unlike where we were with PCBs in the 1970s. They're fantastic classic chemicals that brought a lot of value to society, but we slowly started to realize they also had problems. And we spent a lot of time trying to figure out how to understand PCBs. And we needed to do that before we could figure out the details of the problems and come up with solutions. And I think we're just now with PFAS where we were with PCBs in the early 70s. They're very different from PCBs though. So the tried and true approaches that we've had to looking at environmental impact and toxicity are not working very well for PFAS. And we're having to build a new roadmap.
I think people need to be, we don't want to be ambulance chasers here. We don't want to overplay where it sits in terms of the science today, but certainly people need to be aware of it. They need to know. Be conscious of it. And quite honestly, I think people need to expect that there's more toxicity and exposure data that will be provided to them so they can truly understand what the risks are. That's my
Yeah,
opinion.
as the roadmap develops to understand this class of compounds, we'll get it sorted out just like we did for PCBs,
Right,
but it's just going to take a little time.
right. Yep, patience. Are we looking in the right area? I mean, we do a lot of work right now in testing of soil, testing of water, groundwater. Are we looking in the right areas? Or should we be looking elsewhere?
Well, I think we should be looking more in food. The interesting thing about PFAS that really sets them apart from things like PCBs is they stick to protein.
Right.
Our legacy contaminants collect in fat tissues. These things collect in protein, which means they're going to cause interferences with all kinds of different systems in our bodies, because the proteins are the things that make our bodies work. And so, yeah, that's what sets them apart and what we need to be cognizant of.
Now we have, when we started testing for PFAS, we really limited, or were limited in terms of what we were doing. We did LCM SMS testing. There's, a few dozen compounds specifically that we do test for, but there's thousands of compounds, fluorinated compounds.
Yep, 4,000 to 5,000 is the recent numbers of individual compounds that people know of so far.
So what are the testing tools? Some have evolved over the last number of years. What are the testing tools that people can utilize to do proper assessing?
Well, the workhorse tool for the last 8 years has been PFAS by liquid chromatography with mass spectrometers. And all of the commercial labs are offering this now. We've got some reference methods. It's really a great test. It can get down to the very low detection limits that the current toxicity is telling us we need to be able to reach. But it does have a limitation. As you said, these tests only pick up 30 to 50 compounds out of these several thousand that are out there. And as we build this roadmap to better understand PFAS, we need to figure out where this toxicity is coming from. It's not necessarily going to be with the first 25 that were easy enough to set up because we had standards for them. We really need to understand toxicity in the broader sphere of all PFAS. So the first tool that came down the pipe to help us sort that out was the total oxidizable precursors assay, which some people may know that when PFAS are released in the environment, this dark matter, these 4,000 to 5,000 things that we're not actually measuring, can convert into the ones that we do measure, and some of the ones that we've already started to identify toxicity with. And this is a problem. If you have a site and you try to clean it up and you get it clean to a point where you can't measure PFAS anymore, and then you come back 2 years and environmental microbes have converted some of the dark matter into PFAS, you have a new problem at your site when you thought you were done. So the total oxidizable precursors sort of mimicked that mimicked in the lab that oxidation that goes on in the environment to do this conversion. And that was a really big help. It gave us a glimpse at the magnitude of this dark matter, these other 5,000 things, but it didn't really give us a complete picture. And where the industry is moving to now is total organofluorine. So looking at every chemical in a sample that has that carbon fluorine or organofluorine bond in it. And that's definitely going to help us understand the size of the dark matter and better slice up this class of PFAS so that we can look at different parts of this class of chemicals differently and separately. And it's really going to help us drill down to where the toxicity is coming from and what the things we really need to be aware of is. But also more than that, which things are bioaccumulating, how they're bioaccumulating, how they move in the environment. All these things are going to be much easier to sort out.
That's great. So basically you have 3 different ways to analyze for PFAS. And you would select those based on what your overall sampling objectives would be. Be clear on your sampling objectives. Pick the right way to do the analysis or the right method.
Yep. Yeah, I could see, for instance, using the total organofluorine test and extracting a sample in different ways and monitoring with the total organofluorine in those different types of extracts, and then comparing those different extracts with different toxicity tests to understand where toxicity is, and then using something like LCM SMS to understand what is actually in the components or the fractions that you're interested in.
Right, almost like screening.
Screening, yep.
Oh, fantastic. Awesome, thanks.
Break it down into manageable bites.
Yeah, perfect. Thanks for that. That was an excellent, excellent description. Now we're going to move into the last section, if that's okay.
Oh,
This
yeah.
will be our
Rapid fire.
rapid fire.
Rapid fire. I'll get my seatbelt on.
Okay, Heather, where were
Okay.
you born?
I was born in London, Ontario.
Favorite color?
Purple.
Paint or wallpaper?
Paint.
Tea or coffee?
Coffee.
Big brewery or craft?
Craft.
Me too. Favorite season?
Fall.
If you were a superhero, what superpower would you have?
Teleportation. Yes, I'm a Trekkie at heart.
And if I wasn't busy changing the world through science, I'd be
Woodworking.
good stuff. That's great. Listen, that's all I have for today. I really
Okay.
appreciate getting to know you better. I'm sure the people that are watching did too. So thanks again, Heather.
Yeah, thanks very much, Quinn. This has been fun.
Okay.
Take care. Bye-bye.
Everybody, we'll see you next time on Behind the Science.
Super.